My name's Will, one of the VC team at Climate Investment, probably the last one to say hi today. Just the penultimate item on the agenda today, which is to have the startup presentations. So I can see eager founders in the front row waiting to tell you about what they're doing. So I'm just going to introduce them one by one, they'll pitch, and then on to the next. So I'm sure if you have questions for them, you can bombard them afterwards at the lunch. But we are going to kick off with, of course my phone turned off and locked. Give me a second. So it's Nicholas, the CFO at Naked Energy.
Hi everyone, I'm Nick, CFO and co-founder of Naked Energy, and we are changing energy for good. So for the long term and for the better, both environmentally and socially. And we don't think of energy as an abstract concept. It's about what it's used for and where it's used. And we've touched on this quite a lot over the last couple of days. Just over half of all of the energy consumed globally is for heating. It's a big problem. 90% of that comes from fossil fuels. It's responsible for around 40% of emissions. That's the elephant in the room. Yes, electrification is part of the solution. But where's all the clean electricity coming from? How are we going to get it to where it's needed, when it's needed? And crucially, at what cost to the end consumer? If you're an end user of energy and you want to do something about your carbon footprint and something about your energy bills, you have very limited solutions available, particularly in the built environment where space is at a premium. That's where we come in. We are focused on the provision of affordable, sustainable, distributed heat to the built environment through our Virtue technology, which is a very, very high energy density solar collector. We can produce more energy per square meter of roof space, particularly on flat commercial and industrial roofs, compared to competing solutions. We can produce about twice as many kilowatt hours as leading solar thermal collectors. If we look against the default, put some PV on your roof, we can offset 4 times the amount of CO2 and give you a 50% better return on your investment. We've got 23 patents, we've got design protection, we've got more patents pending. Our business model is very simple. We focus on developing the hardware and the software. We outsource the manufacture to a global giant in that space. We work with partners in different geographies to deliver our solutions. And we also promote directly to certain key industrial verticals. Virtue is the hardware. We've got 2 products, Virtue PVT, which is a unique hybrid collector, produces both heat and electricity from the same area of roof space. And then we have Virtue Hot, as its name suggests, that focuses on higher temperature applications and high heat use applications. Our Clarity software allows us to monitor and control, very important to have access to data to show what a good job we're doing. And our Clarity 360 design software, which we're currently developing, will help us speed up the delivery of our technology to end customers. Underpinning all of that, we see heat as a service being a real catalyst to accelerate what we're doing. What's in it for our end customers? Greater energy independence, that's really key. An improved bottom line, enhanced ESG credentials, particularly Scope 1, and we help increase the asset value, be that the building or indeed the enterprise value. The picture here, you may recognize this building. It's the British Library, an iconic Grade 1 listed building, very difficult to get planning permission to put anything on the roof there. That's our biggest installation to date. It's 1,000 of our collectors, a mixture of Virtue Hot and PVT. It's 350 kilowatts peak. We've delivered that in collaboration with CBRE, and we're just about to start a project that's twice the size of that. We have a great team, very experienced, very good at what they do. None of them were available, so I'm here instead. We're actually here in the UK. We have a team of about 20 people. It's not the sunniest place in the world. We can't import the sun, but we can export our technology. And we're doing that right now. We've sold to over 20 countries. We're having great traction, particularly in Europe. We've got about 12,000 of our collectors now out there on roofs. We did about $1.5 million in turnover in our last financial year, and we expect to see that doubling and tripling going forwards. Here's the ask. We've just launched our Series B. We want to raise 20 to 30 million pounds of new equity funding to unlock our sales pipeline. That's now about 200 million, it's out of date. And that's to expand internationally, to build on the relationships we already have, to build on our push into the United States. And obviously the goal of all of this is to save a lot of CO2. Just as a little sweetener, 20 to 30 million might be pocket change to some of you. We'd also like to talk, as has been discussed over the last couple of days, with people who've got access to infrastructure funds as well. And that means hundreds of millions that we can deploy. So I'll be around for the rest of the day. Please come and find me, ask me some questions. Thank you.
Brilliant. So we're going to have Timo now from Magnetherm, the co-founder and managing director.
Thank you very much. So what we do is we develop a high efficient and zero direct global warming potential cooling technology and get rid of the nasty refrigerant gases and replace them with metals. So I really enjoyed the panels yesterday and especially today, because it's not often that cooling is understood as a very big problem. So especially when you look at data centers, at air conditioning, but also at other areas. Maybe just one number to take away here. 9 gigatons is expected to be the CO2 emissions in 2050 if we don't change anything. And the problem is that we are using for 120, 150 years already the same technology, which is gas compression, which was developed with natural refrigerants like propane and ammonia, which were replaced then by very good chemicals, let's say physically good chemicals like Freon or other refrigerants which have a very high global warming potential, like 25, 30,000 times higher than CO2. So they are now banned in Europe, but also in the US with the F-gas regulation and also with the AIM Act. The question is, what are we doing now? Because there are not many cooling technologies out there, as we learned already from the panel before. And we are actually going back to the natural refrigerants that we used back in the day when Thomas Edison was still around and Nikola Tesla. So this is what we are doing. We have a new technology that uses a metal alloy based on iron that heats up and cools down when you apply a magnetic field and demagnetize the material. And what we can do is then capture the heat and the cold from the metal and put it onto water, for example. So we flush this porous structure of material and then make it to use in different applications. We can also tune the material to very low temperatures, like for liquefying natural gases, in particular hydrogen. So making hydrogen transportable and ready to store where you need it, especially for heavy-duty applications. We talked about ships, aviation, but also ferries and the big trucks. So this is what we can do. So we are a company who come from material science, and we understand this material, and we have evolved into a company that is now a mechanical engineering company, building the cooling systems and building up this ecosystem for this. So this is a very straightforward first application that we're going into. The question is, with this cooling technology, which could be applied to so many different fields, where do you start? And we are actually going to the supermarket first, because with our technology, we can save them a lot of money, especially by introducing our very high efficient technology, which cuts costs on the energy bill. And we are actually able to comply with the F-gas regulations or the specific regulations and provide them with a system that can be interchangeably put in different housings and cabinets. So they're using the same cooling tech, but they use different housings over time. And this is, technologically speaking, a low-hanging fruit. That's why we're going there first. And this is not fantasy. We already put this into realization. So we've built a first magnetic fridge. We are now building the 31st version of this in-house. So it is proven that it works, and we've built up a great team. We're already 40 people. That's due to the fact that we need the chemists, physicists, and material scientists on the one hand, but also then the production capacity, the mechanical engineers, and so on. We've recently closed our seed round, so we are not looking proactively for money right now, but we see already great interest from investors. We also received the EIC Accelerator, where the EIC fund could come in with up to 15 million euros. So if you have money available, then it's still worth talking to us. Just very briefly, what we are currently working at is ramping up the whole supply chain and getting that all sorted out to really scale then the technology. Thank you.
Brilliant. So Matthew is up next. Matthew's the CEO and founder of Ionate.
Afternoon, everyone. So we come to great events like this and we hear about all this fantastic innovation, you know, from startups, but also everything about mobility and AI and data centers. And the problem is, without an electricity grid that can support these technologies, it's a little bit pointless. But as we all know, the grid was never designed for all of these new things to be added to it. And there's big challenges in the physics and how we're going to upgrade the grid. But beyond just that, we need way more capacity of the system. We know that's going to need to at least double. And across all of Europe, across North America, we've got this aging infrastructure problem. And the way that we go about upgrading the grid, it's very rigid and passive, and we just stack on technologies like Band-Aids. And it's very expensive, very complex, and you know, end up with a fragile system. So this system problem is what we're dealing with at Ionate, and you need hardware and software to do that. So for us, the hardware goes in, gives you visibility, which we've never had before, but it also gives you real-time power flow control. Right? That's really crucial. Then when you couple it with the software, you get the system level insight, and you can start to optimize both from a grid edge for kind of flexibility, reliability, resiliency, but also that top-down systemic optimization of the whole system. So the hardware for us, Hybrid Intelligent Transformer, or HIT. So drop-in replacement for a traditional transformer, this fundamental building block of the system. But as I said, we add monitoring, which is really important. Surprisingly, that doesn't exist in the grid at the moment, particularly at like a distribution level, but also that control. So here we're talking about kind of millisecond level control. I don't know if there's any other engineering geeks in the audience like me, but we're talking independent phase voltage control, harmonic suppression, and reactive power, all in one. In real time. So instead of needing a transformer plus stacking on 3, 4, 5 other expensive devices, it is all in a single unit. And the key here is we're actually controlling the power in the magnetic domain. So it allows us to scale up and be a more affordable, reliable, and efficient than any other technology. What's really cool then is when you have multiple devices within the system, the software platform we have can coordinate, control them, and optimize the grid in real time. So we've had independent power system studies done that show that by replacing transformers with HITs, you can get 33% more DERs connected, so EVs, rooftop solar and things, but also 25% more power through the existing poles and wires, and a 6% reduction in losses. So the way that we get the hardware into market for us is we actually work with existing transformer manufacturers. So we license into them, they can build the bulk of the device, we provide them with the brain, kind of like that Intel Inside model, so we can leverage that supply chain, we can leverage them as a go-to-market. And so over this last year or two, we've scaled up to grid scale devices, and we're now going into pilots. So we're doing a pilot with EDP. They have the distribution grid in Spain and Portugal, which we're going into next year. But we're also working with other partners. We're doing a smart city trial with a European capital. We're working with C&I customers like data centers, grid scale battery storage being that connection infrastructure, reducing costs, improving power quality and energy efficiency. And so where we're at today, we did our seed round 18 months ago, led by IQ Capital. That was to scale up the tech and deliver those first pilots. So all of our pilots are paid pilots. The customers buy the hardware. It goes in the grid. It stays there. Now, everyone's started to figure out grid is a big challenge, and we need hardware and software. So in this last 12 months in particular, we've seen massive shift in the industry and a big market pull. And this has meant we want to accelerate, right? We've got a couple of years head start, and we want to make the most of this. So we're now doing our Series A. We're targeting 15. And as you would expect, use of funds for us is about growing the team. So we've got a fantastic, really technically strong team from the likes of, Siemens and ABB background, but we need to expand this. We want to continue to improve on the hardware, increase the product range, scale up to even higher power levels, but also working on that software platform. So this decentralized coordination, we're actually working with University of Oxford and Edinburgh on this. But one of the big challenges is then starting to build out that business development operations side. It's all been founder-led until now, as you would expect. And we simply just don't have the resources to engage with the manufacturing partners, with the customers, and deliver on these projects because there's so much market pull from what we're doing. So look, I think just in summarizing, energy transition is now happening. It's no longer a future thing. 5-10 years ago, it was all about there's going to be a challenge. It's happening today. The money's being spent. And even the IEA is saying that the grid is a bottleneck for this. Thank you.
Brilliant. So now Gary is going to get up, the CEO and co-founder of Up Catalyst.
Great to meet you all. Thank you very much. I'm Gary Earp from Up Catalyst, CEO and co-founder. And in Up Catalyst, we have actually the world's first scalable technology for turning CO2 emission to solid carbon materials like graphite. So, as you might know, there is currently rapid growth of EV vehicles and also EV batteries. So, for each of electrical vehicle battery needs about 66 kilograms of graphite and other carbon materials inside. So carbon is the highest volume raw material for making the batteries. There is no available sources to fulfill that kind of demand, what is there. And looking from the global chart, this market is highly dominated by China. And Europe and also US, they both import more than 98% of the carbon materials they are using right now, and will do it also for the next times as well. And in Up Catalyst, we have really great solution to tackle that. So we can take the CO2 emission directly from the heavy industries, and with our electrolysis technology, we can turn this CO2 to solid carbon and as raw materials for making batteries. So at the moment, we are concentrating on multi-volt carbon nanotubes, and this we can make already as a kilogram scale. Let's say a little bit longer term, we make it also graphite. So graphite is the biggest part we are going to concentrate, and there will be needed for huge factories in that respect. Comparing to the competition, then our materials are much more sustainable. So we use 60 times less energy for making it, and the CO2 footprint is up to 200 times difference there. So the other competitive materials, they emit more than 200 tons of CO2 while they make 1 ton of materials. In our solution, we actually, it's totally contrary, so we consume 3.7 tons of CO2 while we make 1 ton of material. There is a huge market for us to tackle, so we have already validated our materials by different battery manufacturers. We have already made, let's say, pilot production of batteries using our materials. We are waiting for offtake agreements from battery manufacturers listed here. And when we scale up our production to ton scale, then we are ready to provide our materials for a number of the customers listed here. And by revenue, we expect to grow to $500 million revenue by 2030. And by scale-up plan, right now we are finalizing generation 2 reactor, which is capable of making 10 kilograms per day. And next year we are going to build a generation 3 reactor, which already is magnitude 10 times higher, so up to 100 kilograms per day. And by 2030, we expect to produce already 60,000 tons of carbon materials and graphite, and also at the same time utilizing more than 200 tons of CO2. So, and of course, to make it all happen, so we need a really great team. So we have put together all the best experts on that field to make it all happen. In total, right now, actually, this number is a little bit changed. So we have already 25 people and actually 9 PhDs in our team. And yeah, at the moment, we have just recently, actually last week, we closed the first close in a seed round. So we closed 4 million right now. And we are open for raising more for 4 million in next 6 months. So I'm open for this, like let's say, open for investors right now for investing more in this second close in the same seed round for 4 million more. So, and in other respect, we have also 6 million grants that is also secured, and this is top of this 8 million. So thank you very much.
Brilliant. So next up we have Sebastian, the CTO and co-founder at Viridian.
Thank you so much for having us here today. Sebastian is my name, and I'm representing Viridian, a company that is developing, certifying, and also mass producing a battery electric regional commercial aircraft. So we are a seed-funded startup based in Munich, in southern Germany. We have formed a team within only 20 months from 0 to 25 brilliant persons from all over the world, which focus for the moment very much on technology development, because we deeply believe that this is the core to solving the problem that we have in front of us. For the first time in history, aviation is facing very much of a pressure to change towards more sustainability. This has never been the case before to that extent. Aviation has, to be fair, always been improving on itself. So we've always becoming more efficient in our use of energy, but for the first time we have regulations in place that kick in by 2030 really hard. And we have also a society that is demanding from us to change things. And the fastest way to change things in aviation is to electrify it, because the technology is already available. So how does a suitable product look like that is electric? It looks pretty much like a conventional plane, and that might surprise some of us, because when we talk about electric aircraft, we talk a lot about vertically taking off and landing aircraft, but this is a different proposition. It's actually something that is commercially viable for the regional air transport that is connecting the cities with each other. And the big advantage of this is the infrastructure for this type of regional air mobility is already existing. We have these airports everywhere. Europe alone has 3,500 airports, out of which almost 1,000 are capable of scheduled all-weather operation. In the US, you have 5,000 airports. So the key of it all lies in the proper technology. It lies in energy efficiency and in reduction of, or even avoidance of, emissions. We have been busy with the first phase of the company. So the 25 people you've seen have been working on technology development. We are almost finished with that phase. Which is all about the two things you see in the circles. It's first of all building a safe battery inside the primary structure of the aircraft, and ideally you put it into the wings, so you reserve the whole remainder of the aircraft, the whole cabin, for the actual payload to have business. And the second is to have a simple and novel electrical propulsion architecture. As a huge opportunity, we have experienced the openness by the certification authorities to collaborate with, say, most mature startups or companies that are all about certifiability of the aircraft. And we can proudly say that by EASA we have been awarded a so-called pre-application contract to be able to work in a very early phase already on certifiability products, which, being a startup, is a major factor of de-risking the overall project. We want to be type certified with our aircraft before the end of the decade and be in mass production. And the next step is going to be the raising of a Series A, which within the next 2 years is going to make the company bankable in a way that we have down payments by paying customers. How does the market look like? So the first, the left two bubbles are just replacing existing aircraft that are flying around for decades already, and there are no new developments of sustainable aircraft in the segment of turboprops of small aircraft on the radar. More interesting actually is short-haul aviation as a whole, where we typically have the 100-seaters flying around that probably some of you took to come over here. But even more interesting is mobility as a whole, when we manage getting people that today drive their cars, stepping into aircraft, ideally non-emission aircraft, to have a very direct travel between the two cities they are traveling. We are not only selling the aircraft, but we are replacing the batteries, because also in the future the aircraft is going to survive the batteries a few times, and we are going to design the proprietary batteries in a subscription model. The first markets are going to be Scandinavia and Central Europe, because there is an active drive towards decarbonization and towards getting the domestic flights greener. I'll skip that one. We have quite a few advantages, not only in emissions but also in travel time to a compatible price, with the objective of preserving the human dream, which is flying. Thank you so much.
Brilliant. And then just the final presentation for today, and that's Jonathan from Materials Nexus.
So we're trying to build this new world where we just have these kind of sustainable cities, green cities, powered by green energy. But of course, the elephant in the room is that these all require rare, precious materials which come from the far reaches of the world, which are becoming increasingly difficult to access to. Just to name a few of examples, things you may know of, things like lithium, materials which you may not know about, something like terbium, which is basically required for every single light bulb and LED materials that are used, and neodymium, which is used inside of electric vehicles, etc. Just to highlight one specific one, what I just mentioned, neodymium, the market for this is about $20 billion per year, and it's expected to increase significantly over the next 20 years as we require more electric vehicles and wind turbines. What Materials Nexus is doing is to use AI machine learning to invent the next generation of materials which don't require these critical materials from the far reaches of the world. And so fundamentally we're building an AI assistant which can sort of search through the space of possibilities much more quickly than has been done conventionally. And so how this fundamentally works is that we can essentially have a list of engineering requirements, whether it be better magnet, better material for transmission of kind of electromagnetic radiation. We can put this through the AI, and then it proposes novel candidates which can have not only like the same performance as what's existing, but potentially even higher performance. We then do a series of sort of laboratory tests to validate what the AI is saying. We can then file intellectual property against this and then move into the kind of manufacturing scale-up piece. And so comparing this to what's happened traditionally, it takes about 20 years to do this entire process. We're looking to do this process in around 2 years, so significant acceleration required for this net zero transition, which we're all trying to do. The process is very complicated, but basically there's sort of two processes to it. We have the sort of in silico piece, which is we have our own data center in the UK that churns through all of these millions of combinations. We then move to basically trial testing, so we partner with a few labs also in the UK to basically test these input compositions to validate the AI. And then we can do what's called sort of manufacturing trials and validation with large partners. And I can talk a bit more about that later on. And so I think it's important to mention, like, what is the thing that machine learning AI brings to this space of kind of materials discovery, and really the thing that it unlocks is this ability to understand what's called the microstructure. The microstructure basically is the thing which characterizes the behavior of the material once it's kind of been cooled down or cast. So this, if you have like a liquid metal, you need to understand what's called the defect chemistry, and this machine learning enables us to basically do that, and is really our kind of competitive edge over other competition in the market. Just to highlight our plan and strategy in terms of like how we get to scale. So basically we want to become an end-to-end kind of materials producer, and we do this on demand for large OEMs. So usually OEMs approach us and then they say, look, we need a new material for X. We will then basically sort of fire up the AI machine learning. We will invent something, we will file the patents against that, and then we will look to stand up production against initial order qualities and quantities. So one interesting opportunity for us right now is in the US around kind of IRA, which I think is always poorly named, and DOE around, they have significant amounts of capital available to basically onshore a lot of US manufacturing. Team is an excellent team. Just to highlight a few of the names, so Nick is our Chief Commercial Officer, sold over $1 million of products over his career, so very good at sort of breaking into the big corporates. And John, our Chief Scientific Officer, has got over 46 patents to his name, and so understands how to kind of take technologies from the early kind of laboratory stage all the way to production. And of course myself, we've raised over $4 million and got about $600K in UK government grants. And we're joined by a sort of excellent team more broadly across various places from Cambridge, UK National Labs, etc. We've also been backed by some amazing investors, including Cambridge Enterprise and Ada Ventures, just to name a few. And just to sort of highlight sort of where we are commercially, we got significant endorsement from GKN this year, basically to trial some of our materials in sort of real-life production setup in Q1 next year. So just to finish on a sort of point, if you look at materials, something like 50% of all CO2 emissions comes from materials, whether it be transportation, use, or processing, and we think that we can get towards net zero by enabling net zero materials. Thank you.
We're just a couple of closing comments, and we're keeping you all from lunch, so I apologize for that. I was going to interview Nicholas with some thoughts about the day, and I actually will just share my own for the moment. I love the AI, ML, hyperscale computing discussion, and I think one of the things that was a takeaway for me was not just the hammer analogy to the earlier building and construction thing, but that we are in a human capital business. I got started in clean tech investing in 2000 when I was 40. So I'm in my 60s now. And I just listened to 5 really smart CEOs give pitches and tell their story in 5 minutes. I wish I could take you guys back to 2000 and put 5 of the first CEOs I ever thought trying to invest in climate tech were pitching this, and look at the comparison between today and then. It's just dramatically improved. Whether it's because our access to information technology has become global, portable, and communicable, the human capital that we're investing today is vastly more powerful and more efficient than it was 23 years ago, or even 30 years ago. And the access they have to IT resources, to technology, to data, and to human capital themselves is vastly more impressive today than it's ever been. I was thinking about, like, where are we? Like the 2 days today helps me crystallize my own thoughts, which is that, you know, if you think about the Bloomberg data that was shared this morning, compare that to 20, 25 years ago today. The ecosystem we have between seed stage capital, to venture, to growth, to private equity, to pre-public and public markets is robust. Entrepreneurs will not find a shortfall of capital on their journey if they make a cogent argument. Their access to human capital and technology is at an all-time high. So I have this utmost enthusiasm about where the next 10 years goes. Because typically every 30 or 40 years, the whole world changes in significant ways we can't predict. And if I go back to my start in clean tech investing, we're at year 23 of a 30 or 40 year journey. And whether Michael's right, it's going to be till long past I'm dead at 2070, or it's going to happen in the next 10 or 15 years. Things are getting to a tipping point where the industries that we're trying to reinvent are going to tip, and we're going to see it. And I think most of us will see it in, hopefully, our lifetime. So I just want to congratulate the entrepreneurs we heard from yesterday and today. Congratulate the TDK Ventures team a lot for the learning, the sharing, and then that whole human capital side is great to have everybody here, because it's not just these 2 days conversations, it's the ones that get picked up from the people you meet and the conversations you have. So I just want to thank you guys again.
Thank you, Mark. And I am so thankful first to the teams, Climate Investment team, TDK Ventures team. I think it's our best energy week ever, full of energy, pun intended. But I think, like you said, it's a very long journey. This is an energy transformation that will take decades. But we need to have this, I like to say, patience and impatience, the sense of purpose, but also the sense of urgency. We need to get started now to make sure that the impact compound. And it takes a long time to do that. So the long journey is definitively one thing. But today, what I also liked is we talked about the fact that we're working on something that's not always sexy, like buildings. But it really matters. It really moves the needle if we do it well. I think what we also learned is things that are sexy may not be so good for us right now if we don't work on it, like generative AI and all the impact it has on our precious resources. So I just want to reiterate actually our code of conduct, because that's our core values at TDK Ventures, and so that you know what to expect from us. You know when to reach out to us. You know how to partner with us. And so the code of conduct is C for contribution to society, which is really the underlying themes to everything we've talked about in the last 2 days. O is one team reaching for the sky, and I'd like to think that we are all part of this team wanting to accelerate this energy transformation to net zero, but in a very smart way. D is delivering deep insights, which I think hopefully you all agree we did in the last 2 days really well with amazing speakers, amazing entrepreneurs. And that leads me to entrepreneurs first, the E. And we always say entrepreneurs are our customers, the hero of our stories. Actually, it's not just the TDK Venture story, it's our society to improve the planet. So a big thank you to all the entrepreneurs here today and online. We need you. Thank you.